Hello my dear students, welcome to the Narcotic Analgesic series, and today in part 7 we are seeing mixed agonist and antagonist and pure narcotic antagonist. So this is a classification of narcotic analgesics, and the second class is narcotic agonist and antagonist, or I can say that mixed agonist and antagonist. So in the last lecture, I discussed with you that people, when initially trying to synthesize a derivative of morphine to get such kind of molecule which is free from or devoid of habit forming tendency, so rather than getting agonist, they got agonist and antagonist. That's why the separate series has been developed, and that is called as a narcotic agonist and antagonist. So why it is called as agonist and antagonist? Because this compound, as you know very well, that these compounds are binding at 3 different receptors, that is mu, kappa and delta. It means that at one receptor they are acting as agonist, and at 2 receptors they are acting as antagonist, and hence they are known as mixed narcotic agonist and antagonist. Example is pentazocine, nalorphine and nalbuphine. The third category which we supposed to study today is narcotic antagonist. So as I told you in the last lecture, that they try to synthesize morphine derivatives, okay, but rather than getting the agonist, okay, they got the exactly opposite drug called as an antagonist, okay, and in this way the third class has been developed, that is known as narcotic antagonist. So in detail we will be studying a narcotic agonist and antagonist and narcotic antagonist today. So these are only 2 structure which is there in your syllabus, that is pentazocine and phenazocine. Now how to remember the structure of pentazocine and phenazocine? So in pentazocine you can see that cyclic ether part is removed from here, only 2 rings are there, and third ring, that is cyclohexene, is also removed, okay, and only this propene side chain is there, which you have to remember. On the other hand, in case of phenazocine, the word indicates that phena, it means that it is very similar to the pentazocine. And why the name pentazocine is given? Because you'll find that it contains 5 carbon, 1 2 3 4 and 5, 1 2 3 4 and 5. That's our name is given, and that's our name pentazocine is given. Now why phenazocine is given? Because at here you'll find a phenyl ring. The structure is very similar to the pentazocine, okay, only difference is that it contains phenyl ring, and hence it is called as a phenazocine. And when you need moderate type of analgesia, okay, in that cases we are using the narcotic agonist and antagonist type of the drug, that is the pentazocine and phenazocine. This is therapeutic application of this category. Now we are moving to the next and the last category, that is a narcotic antagonist. So these are 3 examples which are there in your syllabus, that is naloxone, naltrexone and nalmefene. So how to remember the structure of this compound? So the whole structure is similar to the morphine, okay, the word naloxone, so it gives idea that it contains a ketone, so you have to replace one of the hydroxy group of morphine with ketone, so the name will be the naloxone, and here you have to remember this propene side chain. The next is naltrexone. Again there is no any kind of relationship between the name and structure. It is very similar to the naloxone, only cyclopropyl ring is here, okay. In nalmefene, it is very similar to naltrexone, only thing is that they have removed ketone from here and added hydroxy to this carbon atom. So in this way you have to remember the 3 structure: naloxone, naltrexone and nalmefene. Now what is the therapeutic application of this 3 drug molecule? So you know well that people, they are addicted to the morphine, and in case of overdose of opioidal drugs like a morphine, these antagonists are useful to reverse their effect, okay. So in this way here the whole chapter ends. So we have seen narcotic in the whole chapter we have seen the narcotic agonist and antagonist, and the last is a narcotic antagonist. Now we are moving to the nomenclature. So most of the time in examination they are asking about the IPC nomenclature and synthesis of mepiridine. So as usual, our three rules are there in the nomenclature. So first rule is that decide the parent. Okay, decide the parent. This is our first rule. So here I am assigning this pyridine ethyl carboxylate as a parent. Okay, sorry, piperidine ethyl carboxylate. So you can see that this is piperidine, this is piperidine ring. Okay, this is a ethyl and this is a carboxylate group. So I am considering a whole as a parent. So as usual, the name of parent should be written at the end of nomenclature. So I am here writing piperidine. Okay, 4. Okay, this is a 4 ethyl, this is ethyl. Okay, carboxylate. Rule number 1 is over. So rule number 1 is decide the parent. Rule number 2, give the numbering to the parent. Okay, and I start giving numbering. So I have to start from here 1, 2, 3 and 4. And rule number 3 of IPC nomenclature is that assign the substitution. So you can see that substitution is available on after number 1. So you can say that 1-methyl, or you can also say that N-methyl. So that's why 1-methyl or N-methyl. Okay, and at carbon number 4, okay, you can see that which substitution is there? Phenyl is there. Okay, that's why you have to mention 4-phenyl, and the whole parent is, what is the name of parent? Piperidine 4-ethyl carboxylate. Okay, so I hope that you have understood the nomenclature of mepiridine, and in this way the whole chapter ends over here. And thank you for watching this lecture, and if you have any kind of query in your mind, feel free to write down into the comment box. Thank you.